In the diagram below, Q is the center of the circle, which intersects the y-axis at P and S, respectively. So, what do I have? I have Q as being the center of the circle, so I already know that this is supposed to be Q, just excuse that. And then it intersects the y-axis at P and Q, so I have P and S rather there. And then the tangent ABP, which is this one here, intersects the x-axis at B and makes the angle alpha with the positive x-axis, which is this angle down there. And then also R is a point on the circle and PRS is equal to theta. So PRS is equal to theta, which is this angle that I have down here. Now, let's look at the first question, what they want us to do. Determine the equation of the circle in the form of x minus a all squared plus y minus b all squared is equals to r squared. So one thing that you guys need to know here is that the value of a and b is the center of the circle that we are dealing with. So this is the center in this instance, which is the coordinates of q. And then lastly, the r is the radius of the circle. So those are the two things you need to know about that equation I'm giving there. So this will be x. Now the center of the circle, which is coordinates of q, was 5 and 2. So this will be x minus 5 squared plus y minus 2 all squared is equals to r squared. And then from here, what I will then need to do is I will then need to substitute any point that lies on the graph. In this instance, I have the point 0 and 6. So I will have 0 minus 5 here, all squared plus a 6 minus 2, all squared is equals to r squared. So minus 5 squared is 25 plus then 6 minus that is 2 squared will then be a 16 is equals to r squared. Therefore, r squared will be equals to 25 plus that will then be 41. So this will be the r squared. I don't want it to be rs yet because I'm just going to substitute it there still. So this will be x minus 5 squared plus y minus 2 all squared is equals to 41. So that will be the equation of this circle that they want. The next question, calculate the coordinates of S. So I want the coordinates of S. Now looking at where the S is, what I know is that from S to that point, which is point Q, the distance is the same as from the point Q to the coordinates there of P. But right now, the other thing that I know about the coordinates of this is that this is 0, the x value is 0 there, and then the y value is what I do not know. But I also know that this is supposed to be a negative. So those are the two things that I know about that. So my equation, as we did the other page, we said it was x minus 5 all squared plus a y minus 2 is all squared is equals to 41. So now I know that the x value here at that coordinate is 0. So I will then say it's 0 minus 5 all squared plus y minus 2 all squared is equals to 41. And that's what I want to find. I want to find the y value that corresponds with this 0 that I have here. So this will be the 25. And then this will be plus. If you FOIL out this, it will be y squared minus 4y plus 4 minus 41 is equals to 0. Remember, immediately you see a squared, it means that you must write it in standard form where you equate it to 0 so that you can factorize. So this will be y squared, then minus 4y is a like term on its own. Then 4 plus minus 41 will be a 37. Then 37 minus 25 will give me a 12. So this will be minus 12, so equals to 0. And then from there, I will then have to factorize this. To factorize this, I will then say it's y minus 6 and then y plus 2 equal to 0. Remember, minus 6 times 2 is minus 12. Minus 6 plus 2 is minus 4. So my y values are y is equals to 6 or y is equals to a negative 2. Now, why I'm getting 6 and negative 2, or rather 6, which is what I already have there, it's because this is also corresponding with a x value, which is 0. So this 0 that I had here corresponds with 2 points, which is P and S. That's why I am finding those. Therefore, I will then say that S is 0 and negative 2. And now remember, it's a tick there because I had said that it must be a negative, and also it corresponds with the x value, which is 0. Then determine the equation of the tangent AP B in the form y is equals to. Now what I need to know about this is that I know that the tangent is perpendicular to the radius. So that's one thing I know about a tangent. And also, if that is the case, it means that the gradient of the tangent multiplied by the gradient of the radius will then be equal to a negative 1. So that's one thing that I know about it. Now I have my tangency point, which is the point P there. So quickly, the gradient of the radius will be y of y2 minus y1 over x2 minus x1. So this is the m for the radius, and this is going to be equals to y2. I will take it as the coordinate of q there, so it will be 2 minus 6 divided by 5 minus 0, which is equals to 2 minus that, it's negative 4 divided by 5. So this will be my my gradient of the radius. If this is the gradient of the radius, it means that the gradient then of the tangent will then be equals to a positive 5 over 4. That's number 1. Therefore, I have y is equals to 5 over 4x minus, or plus rather c, sorry about that. And then I use the coordinates of the tangency point. The coordinates of the tangency point will then be the 0 and 6. So I will have it as 6 here is equals to 5 over 4 multiplied by 0 plus c. Therefore, c will be equals to, so I have 5 over 4 times 0, which is 0. So c will be equals to a 6. Therefore, my equation is y is equals to 5 over 4 x plus 6. And that will be the equation that they want. Now, matrix, what I've been looking at right now is an equation of a circle whose center is not at the origin. Remember, if it's at the origin, it becomes x squared plus y squared is equals to r squared. But we include the value of a and the value of b, given that we have the center not at the origin. That's number 1. Number 2, to find the radius, you then substitute any point that you find on that particular circumference of the circle. And then the third one is we looked at the equation of a tangent. The equation of a tangent, we must make sure that we have the coordinates at the tangency point and also at the center, so that I can find the gradient of the radius. If I know the gradient of the radius, then I know the gradient of the tangent, because the product must be equal to minus.